Hello guys, and in this video I want to show you how to make this Minesweeper clone in Pygame using Python. So let me just show you what it looks like. So this is the actual window of the ready code that I have. And if you don't know how to play Minesweeper, you have a grid and you have mines around this grid. So we need to avoid the mines basically. So we would click on a square and you will open up like that, and you have some clues. So this clues means each of these numbers means that there is that amount of mine around this number. Okay, so for example here there's a number 1, so there is 1 mine around this number 1 here. So in this 8 square grids, not counting the middle, there's 1 mine. As we only have 1 square in here, so that is a mine. So you can right click and it places a flag. We know that's a mine. As we have a mine in here, we have a number 1. We know this one is a mine, so this one cannot be a mine, okay? Because it's directly connected to this one, but this one is already a mine. Same here, the corner, we have a mine in there. This one we know it's not a mine, that, and then anything that is around this one in here is not going to be a mine as well, because there's already a mine there. So we can kind of open up all of it, and then it opens up like that. Okay, this one as well, we know it's not mines. This one is a mine. We can kind of open up like that. And you can kind of play the game like that until you find all the mines. Okay, so if you step on a mine, this is what happens. It reveals all the mines, and the one that you stepped on, it highlights red like that. All the assets for this game will be in my GitHub alongside with the code. So if you want to follow along this tutorial, just go to the link below on the description. It should take you to my GitHub, to the page of the Minesweeper. Just copy the assets and place it into a folder, okay? I'm just gonna do that actually right now because I haven't done it yet. So I've created a Minesweeper folder in here, and inside of this folder I have 3 Python files. So I have main, settings, and sprites, okay? As in all my other games, I always use these 3 files to create games. And then inside also of this Minesweeper folder, I'm just gonna paste in this assets folder, okay? If you go in there, in this assets folder, it will find all the image that you need. I believe I took those images from another video, from another person, so I don't hold copyright or anything. I mean, it is the image of the actual Minesweeper, I believe. So you have all of this in there, okay? So they exploded, the flag, the mine, not a mine, and so on, okay? So as soon as you have those assets inside of that folder, let's start with the tutorial then. We're gonna start with the settings file. Or actually, let me just show you the main as well. So I went ahead, I already typed in this class game. So if you need, you can just pause the video in here. There's everything on the class game that is written on this code is already in here. We create a class game, we define a constructor, which creates a window, set the title or the caption, and creates a clock. We have this new function, which has nothing inside, which is gonna be to create a new game. And we have the run function, which is the game loop basically. So it runs the clock, FPS, the events, the draw, the update and the draw. Actually, the update, it shouldn't be here. We won't be needing an update for this. So instead of having the update in there, we're gonna have just events and draw, because as this is a click-based game, okay, so we don't need to actually update anything. We'll do all the updates when we click. So if we click on a tile to review, we'll do all the updates in there, and we'll call some functions and do the updates in there. So I'm not gonna be using that update function in here, okay? Just to get rid of this update function. In the draw function, we are filling the window with this background color, which I'm gonna show you in the settings code in seconds. We flip in the display, and then the event function, just a simple event to when the user click on the X button on the window, it exits Pygame without any error. Okay, then in here, just create an instantiate object of game, put in a while loop, we call new and then run. So once this run function stop running, it will call new again and it will create a new game basically. Up here, we're just importing Pygame and then everything from settings and sprites. Okay, in the settings file, I have all the colors already copy and paste in there. If you don't have those yet, you can just pause in here really quick, just copy. These are just constant for all the colors containing the tuples as this value, so RGB. And the sprite file, there's nothing on it. I'm just importing Pygame and importing from the settings everything. Okay, let's just start with this settings file here because we're going to be importing all of the images. So we have the game settings. We'll just create a constant, some other constants in here. We're gonna have a tile size of 32. You can possibly have that bigger or smaller if you like. I just like it 32. It's a good size, I think. We're gonna have rows, which is 15, and also columns, which is 15. That is just how many rows and columns our game will have. So you can increase or decrease that according to a preference. And also the amount of mines. Okay, I'm going to set that to 5 just so we can do tests and all of that. In my normal game, I think I have that as 30, the one that I was just showing you. And then we'll have just the width and the height of the window, which is just gonna be the tile size times the rows, and then the height will be the tile size times the columns. Okay, that is just so that the window size is going to be exactly the size of the boards. So if you increase these rows and columns, your window will be bigger. Okay, FPS will be at 60 for now, and then just a title which is going to be Minesweeper. Let's put Minesweeper clone. Okay. And we can try to run that, just the title in here. We need to change that. It's just because I put caps as a constant and before was just lowercase, that's why I changed it. If we run this, we should have this window here. Okay, so that is the size of our board, and we can close it because we've done the events already. Finished with a exit code of 0. Okay, the next step in here is to just import all the assets. Okay, so we're gonna take all the assets and we're gonna import them in here. We're gonna create a tile numbers list which will hold all the numbers, and we're just gonna do a simple for loop in range from 1 to 9 basically, because the numbers goes from 1 to 8. You can have up to number 8. That means all the mines around the number 8, it's all the squares around the number 8 is a mine basically. And then to import those, we're just going to append a pygame.transform.scale, and then we actually have to import we're gonna import Pygame in there, and we also have to import OS because we're gonna have to use the OS in here. So pygame.transform.scale, and then inside of here pygame.image.loads, and then os.path.join, and then we'll do assets, comma f-string, and then tile i.png. I'm gonna show you that in a second, okay? Then you exit out of 2 brackets, comma, tuple, or brackets again, tile size. Okay, so basically what's happening here, you see the assets, they have the numbers, is like tile1.png, tile2.png, tile3.png, and so on. It goes from 1 to 8. That's why we loop in range of 1 to 9, because it's not included in 9, so it goes from 1 to 8. and we are just using transform to scale this image to the tile size by tile size because it's a square. And then we're just using the image loads and the OS path join just to join this folder and then call this file, okay? And we're just putting those inside of this list here. So we're gonna use them later. Let's just finish importing all the other tiles. So they're gonna be very similar to this. So you can actually copy and paste all of this. And the first one is gonna be tile empty. We'll just paste it in there. And then instead of tile number, it's gonna be tile empty.png. And then we'll just press, if you select this, your cursor, press Control Command D, it will just duplicate. And then we'll have exploded, which is gonna be tile, tile exploded. We actually do not need the F string in here anymore. Get rid of that. The next one is gonna be tile flag. And then in here is tile flag. Next is tile mine. And then here is tile mine. Next is tile unknown. And then here, tile unknown. Duplicate, tile not mine. That's the last one, I believe. Not mine. Okay, so that's all for the settings file here. I'm just gonna close this for now. And the next thing we're gonna do is we're going to go to the sprite class and we're gonna create a tile class. We're gonna create this class for the tiles, and that's gonna have a constructor with the X and Y position, an image. So which image it's in the tile, a type. So this type in here, it's gonna be, we're gonna be passing something like this for the types, okay? So if it's a dot, it means it's unknown. If it's a capital X, it's a mine. If it's a capital C, it's a clue. And if it's a slash, it's empty. Because on the board list, when we create the class board, we're gonna be holding those values in the list and to compare again. So we're gonna have a 2D list, which is gonna be our board. And then whenever we click on something, those are gonna change around, okay? So that is what is that type in there. And what else do we have in here? We have a revealed parameter, which is gonna initialize as false because all of them are gonna start as false. They're not gonna be revealed. And also a flagged, which is gonna start as false because none of them will be flagged in the beginning. Self.x, self.y. Okay, this is going to be x times tile size, so we don't have to do that later. And tile size is just because in here we're gonna be passing a board value in there. So 0, 0 is the top corner, 1, 0, and then so on. So the board value, and then we're just gonna multiply that value by tile size to get the pixel, so where we have to actually blitz this tile, okay? So that's why we are just multiplying that already. Self.image equals to image, self.type equals to type, self.revealed equals to revealed, and last one, self.flagged equals to flagged. We're also gonna just define override the representation under function just to return a self.type. I don't know if really we're gonna use this, but just so we can print the board and you return the type. So it's gonna print like a board and it's gonna show all the types. For now in the tile class, I think that's it. We're going to, let's just create this board class so we can start creating the tiles and then drawing them into the screen so we can see what's happening. So the board class is gonna have a constructor. Let's make it a board surface, which is a Pygame.surface, and this is gonna be rows times tile size, which is the same as the width and the height, right? Tile size times row, yeah. We're just passing the width and height in here because the board is gonna be the same size as the window basically. This is gonna have a list in here that can hold all the tiles. That's what we're gonna create now actually. Let's create this board list. And this board list, I'm just gonna do an inline for loop in here. We want to create a 2D list containing tiles, okay? So we're gonna have a tile, so tile objects, okay? And then we're gonna have many of this like that. So it's a 2D list, okay? So we have many rows. So as many rows as we have, so in this case it's 15, and how many columns we're gonna have in there, which is 15 as well. So this is the board list, okay? And we're gonna have those tiles objects in here, and then we can print this board list in a nice format, and instead of printing class tile, it will print the representation of that tile. I hope that makes sense. I'm gonna show you what I mean in a second. So we're going to do 2 lists like this, and then this is gonna be tile, and we're gonna pass in a column row, tile empty for the image, so it's gonna start empty, and then the tile type is the unknown, okay? So this one, the dots, and then we exit out of one bracket. It's gonna be for row in range of rows, exit out of the first list for column in range of columns, okay? So if you don't know, this is just a inline for loop. It's basically a nested for loop for row in range of rows and for column in range of columns. We append this tile object containing the row, the column and the row, a tile empty as an image, and this dot as a type to a list, okay, to the board list. Let's just create a function here that called display boards, just so I can show you what I mean. That's gonna be for I in self.boards list. We'll print I, or let's do row, I guess, for row. Let's go to the main. In the new function here, we're gonna create a boards, okay, and we'll just call boards.displayBoards. Let's see what this does. Okay, so this is what we have. This is what I mean. Okay, so we have a list and we have many rows, all with dots because they are all unknown. Okay, so we don't know what they are yet. So that's what I mean by the self.type in here, okay? The representation. If we didn't have this dunder function, when we run it, this is what you're gonna get, okay? So you're gonna get the object. So it's a sprite, it's a tile object at the memory location, blah, blah, blah. So we don't really care about this. That's not really important. That's why I'm overwriting the representation dunder function from the tile class to return the actual type. So that's why we see this nice and neat dots in there. Okay, let's just go back into the tile and we're going to define a drop function in there. And this draw function, we want to actually draw. So we're gonna take a board surface because we're gonna be drawing into the board surface, and then the boards we're gonna draw straight into the screen. And what we want to do in here, we want to take the board surface dot blit, and let's just blitz a unknown tile for now at self.x and self.y. For the boards, we're gonna create a draw function as well for the boards, which will take a screen. And to draw the board, we're gonna do for row in self.boards lists, and then for, let's say, tile in row. So every tile in the board list, we'll do tile.draw, and we pass in the board's surface. And then we'll do screen.blit, and we'll blit the board surface at 0, 0. So at the top left corner of the screen. Now we'll go back to our game in here. In the draw function, we'll just do boards.draw, self.screen. When I run this, this is what we have. Okay, we can't do anything yet, but we have all the unknown tiles drawn into the screen. Let's go back into our sprite file. Let's place the mines. Okay, so we have all the unknown in there. Let's just go back in here. Instead of blitzing on the tile in the draw function, let's just blitz the self.image in here actually instead of tile unknown. I'll show you why later. So now they're all empty basically. Okay, so the dot means it's empty. So they are all open like that. We're just gonna draw the image now because we're gonna add the mines and the clues, and then we want to actually see it, everything, to see if everything's in the correct place basically. So let's place the mines first. We define a function called place mines, and in there we're going to do a for loop in range of the amount of mines. Okay, so we need that much mine, so in our case it's 5, I think. And then we're going to just do a little infinite loop in here, because we want to get a random location for the mine to be placed on. Okay, so every time we go through this, we're gonna check for a random location, and then we're gonna try to put a mine in there. If there is already a mine in there, we don't want to place it again. Okay, we want to loop, we want to do this again. We want to check for another random location and then place a mine in there. Okay, so we're gonna keep looping on this until the random location that we choose doesn't have a mine on it, and then we can place a mine on it. So what we're gonna do is we're first gonna generate the random integers. So random.randint from 0 to rows -1, that's the x, and then the y value is gonna be columns. Okay, I know they're the same, they're 15 right now, but I'm just putting like this in case you want to change, you want to make the boards wider or higher, I don't know. But right now they're the same, so it doesn't really matter using rows and columns. I could use rows for both of them if I wanted to. And then, so we generate the x and y coordinates. So it's gonna go from 0 to rows -1, so from 0 to 14 in this case. And then that is gonna give me a index that I can place. So I'm gonna check the board list, and we're going to, so self.board list, x, y in there. So we want to take that tile and we just want to change its image for a tile mine, and we also want to change its type to be a capital X. Okay, so that is the type for the mine that we have in here. Let's see if like this is gonna work. I think in my other code I was actually just adding another tile to this block, but since we already have a tile in there, an object, we can actually just change the image and the type. Let's see if that's gonna work. Okay, so going back to this, This is gonna loop through, it's gonna generate a random location to place a mine, and then we're just gonna place that mine basically. Okay, so we change the image to tile mine and we change the type to X, and then we just go and do this again. Okay, but we need a condition here because we need to break out of this loop. So the condition in here is gonna be if the self.boards list in this position dot type is equals to empty, then we do this, and then we can break. Doing this, that might be a possibility. That is a very small chance that it keeps giving you the same number over and over again, and then you just get stuck on a loop. It's very rare the chance that will happen, but it can happen. There's other ways of doing this. I just like doing like this. Okay, so that is it for this. We're going to be calling this place mines at the top here, and let's run it. What's that gonna happen? Okay, there we go. Right, so we place 5 mines randomly on the boards, and you can see here we're displaying the board still, so we have that, see, like that. So if I try running this again, you see the mines are in different places. Every time the mines are in different places. Now we have to place the clues. Okay, we're gonna create a function in here that's called place, that's called clues, and that will be the numbers. Okay, and I think we're gonna have a couple more functions to go with this. We need that, and then we're gonna have a function that check neighbors, okay, which will take an X and Y. We're gonna loop through all these squares, right? And then each square we're gonna check all the neighbors, but not the square that we're checking, obviously. And if there's any bombs around, we're gonna add to a counter, and then at the end we're going to add the equivalent number to it. So for example, this square here is gonna check here, here, here. They are not bombs. This not bombs. This one not bomb. This one, yes, 1 bomb. So adds to a counter. So counter is number 1. This is not bomb. Okay, so this should be number 1. Okay, and then so on. So if you have more bombs around, then the number will increase. In this case, I think we'll have only once, but I'm gonna increase the amount of mines so we can test the other numbers as well. First, we're going to code these check neighbors because we're gonna have to call these check neighbors in here to place the clues. So let's just code this one first. And we're going to also have a function in here called is inside. This can also be a static method. Oops. Is inside, and then that is just going to return if we are inside of the board. Okay, I'm gonna take an X and Y in there, and 0 less or equals to Y less than the columns. Okay, so this, we're gonna be calling this function in here just to check if we are, if the neighbor square that we're checking is actually inside of the board, because if it's not, we can't check, because otherwise it's going to give you index error when you pass into this list in here. Okay, so what we're going to do in here is we're going to create a variable called total mines. We're going to initialize that as 0, and we're going to do a loop in here. So for X in a range of -1 to 2, I'm going to explain that in a bit, and for Y in range of -1 to 2. Okay, what this is doing is, let's say we're checking this square here. Okay, we're checking all the squares around. So first square we need to check is this one on the corner here. So that square is one less on the rows of this row here, and one column less to the left of this column here. So that is because that's why we have -1. We start at -1 and then we go to 1, to 0, and then we go to 1. So that's -1 there, 0, and then 1. Same for the rows, -1, 0, and 1. Okay, that way we check all of these tiles around this specific tile that we're checking right now. I hope that makes sense. Let's just continue with this. So we're gonna create a variable called neighbor x, which is equals to x plus, so we're gonna have to actually call this x offset, and then offset, because we already have the x and y here, so we can't call them x and y again. So this is x plus x offset. Same thing for the y. The y is going to be y plus y offset. Okay, this in here is because we're going to be calling this function. We're going to be looping through the boards, and then we'll call this function for each tile. So we need to send the tile that we're checking, so the coordinate of the tile that we're checking, we need to send it in here. And then we'll take that coordinate and we add the offset to it. So if it's -1, is 1 to the left, and -1 and 1 to the top. So that's the one on the top corner, neighbor of that square that we're checking. Okay, continue with this. We need another if statement in here. So now if is inside, so now we need to check whether the neighbor x and neighbor y it's inside of the boards. Okay, if it's not, and you don't have this check, then you will loop through it and you give you an error, you give you an index error, because you're going to try to access an index that doesn't exist on the board. Okay, and self dot board list neighbor x and neighbor y is equals to a mine. Sorry, dot type as well. Dot type. Okay. So we want to check if that coordinate is inside. If it is, we also check if that neighbor is a mine. If it is a mine, we add 1 to the total mines. Okay. And then at the end, once we do all that loop for each of them, we just return total mines. Now, going back to this place clues function, what we're gonna do in here is we're going to do a loop again. So nested for loop in range of the rows. Okay, and also in range of the columns. So we're just gonna loop through all the rows and the columns on the board list. And we're going to do if self.boardList x y dot type is not equals to a mine. Okay, so if it is a mine, we're not going to check for other mines around, because we can't change that mine to a clue basically. If it's not a mine, then we do total mines is equals to self.check neighbors at x y. Then we call this function here. Okay, and then if total mines is greater than 0, okay, so if we have found a square that needs to have a clue on it, we'll do self.boardsList x y equals dots image equals to tile numbers total mines -1. And also we need to change its type to be C, which is a clue. Okay, let's run this and see. Okay, nothing's happening because we're not calling that. We need to call self.place close. Let's see. Okay, that's what we're getting now. So we have all the clues, they are in the correct place. Let's go back into the settings. I'm just gonna put like 40 mines in there just to test it. Yeah. Okay, let's see if we see anything. So 4, we have 4 mines around. 1, 3, we have 3. 4, we have 4. 5 in here. 1, 2, 3, 4, 5 mines. Yeah, that's good. 1, 2 mines. Yeah, I think this is all correct. It looks good. And then every time you run it, it's randomized basically. Okay, it's totally different. And this is what our board is looking like right now. So the empty space, the mines, and the clues. Yeah, so just to remind you guys, like the types, it's for this, so you can see how the board is looking like if you want to, but it's more like for us to check. Okay, it's just easier. I mean, you can check against the image in here and see if the image is equals to whatever image you're looking for, the mine image. But I just prefer having this type variable. It's just one more variable that you just add in there, very easy, and you just add the type. I just created like a type list for it. Having each of this as a type, it's just a bit easier. So now we want to, so right now we're just blitzing the image into the board like that, so we can see all the board basically and all the mines. We don't want that, we want to hide everything. So let's just go back to our tile class. In our draw function, we just want to change some stuff in here. Okay, because we have the revealed and the flag variables there as well, so we're going to be using those in here. So if not self.flagged and it is revealed, we want to display the image. Okay, so if it is not flagged and it is revealed, we just display the actual image. So it's either a mine or a number. Elif, if it is flagged and not revealed, we want to blit a tile flag to it. Self.x, self.y. Okay, so whenever we right click on it, this will change to true and the revealed will remain false because we haven't revealed it. And then this is going to trigger and it's going to blitz a tile flag to it. Now, last if statement, if it's not revealed, so we haven't been revealed yet, we will blitz a unknown tile. So that's what we did in the beginning basically. That was showing all unknown tiles. So now if we run this, we see all the tiles are unknown basically. Okay, we can't do anything yet, we can't click on them. Okay, we are going to go back to our main function. We're going to create the events now. The events are going to be for the mouse clicks mostly. Well, I think it's all mouse clicks because you can click, or you can left click to review a tile or right click to flag a tile. So that's what we're gonna be doing here. So for if event type is equals to pygame.mouse button down, we will take that mx and my pygame.mouse.get position. We're gonna take those and we're going to integer divide them by tile size. Okay, because we want to check which tile we're clicking, because we're going to be using those against the boards list that we have, and we can't be using the boards list, we can't be using pixel data in there. We need to use a proper index in here. So that's why we're just integer dividing by tile size. So that is going to give me the tile size. So now if we run this, we see all the tiles are unknown basically. Okay, so if it is not revealed, we want to display a tile flag to it. So if it is not flagged and it is revealed, we want to blit a tile flag to it. Okay, so now if we run this, we see all the tiles are unknown basically. Okay, so if it is not flagged and it is revealed, we want to display a tile flag to it. the exact location of each of the tiles. And then we're gonna do here, if event.button is equals to 1, that means it's the left button click. If not, self.board list mx my, so we are taking that board coordinate, we're checking that specific tile that we're clicking on. If that tile is not flagged, okay, because if it's flagged and you left click on a flagged tile, nothing will happen basically. Okay, so you need to unflag first before you can reveal it. So that's why we're checking. If it's not flagged, then we're gonna dig. Okay, so we're gonna dig and also check if exploded. Okay, we're gonna be creating that dig function later on the boards class. Okay, so for now I'm just gonna put a comment in there that if it's not flagged and we left click on it, we want to dig. Okay, and then just reveal all the tiles around if it's an empty tile basically. And if event.button is equals to 2, sorry, not 2, 3. So 2 is middle click and 3 is right click. And then we'll do that again. So if not, self.boards list mx my dot revealed. Okay, so if it's not revealed yet, then we need to add a flag. We can't add a flag to a revealed board. Okay, I will just pass this in here for now so we don't get any errors. Okay, so if it's not revealed, then we just want to take the boards list mx my, and we're going to do flagged equals to not flagged. Okay, so just copy that, not flagged. Okay, so every time you right click on a not revealed tile, we want to change that tile. So if it's not flagged, we'll change to true. If it is already flagged, we'll change to false. Okay, let's just test this to see if it works. Yeah. Okay, so we can right click on any of the tiles, and if you right click on them again, you can remove the flag like that. Okay, let's create that dig function. Okay, so back to the sprite file, we're going to come back, we're gonna come down maybe after the drawing here. This is the algorithm that basically it's gonna call itself. So it's gonna be a recursive function that will call itself. And this is the most difficult part of this code basically. Okay. This dig function, it will take an X and Y. So the coordinates on the board list that we want to reveal. And for that as well, in the constructor in here, we're gonna create a self.dug function. Variable, which is going to be an empty list. So we're going to be storing all the values that are already dug out in this list. Okay, because once we're calling recursively this function, this dig function, if we're going to be checking if we already dig that hole or not, or that square, that tile. If we already dug that tile, if it's already inside of that list, we don't need to do it again. Okay. So this dig function, first thing we're gonna do is we're going to append this X and Y into that dug list. Okay. This needs to be a tuple, sorry, X and Y like that. And then we have a few checks in here. So if the board list X, Y dot type is equals to a mine, okay, so the capital X, it means a mine. So if we click on a mine straight away, we need to do self.boards.list X, Y. We need to change the type, we need to change the revealed to be true. And also we'll change the image image to be the tile exploded. Okay, so that means if we straight away we click on a mine, we want to explode, and then we change that tile to a exploded tile image, and we also going to reveal it so we can see that tile. And then we'll have an elif in here, which is going to be if the boards list x and y dot type equals to a clue. So it doesn't matter what number it is. If it's just equals to a clue, then we'll do boards list x y dot revealed equals to true. So we just want to reveal that. Okay, so if we click on a clue, we will reveal it. Or the algorithm, once it's calling itself, if it runs into a clue or into a number, we should do that. We reveal it, and then we have to return this true as well. Because once we hit a number or a clue while we're revealing all the tiles, we want to stop. We don't want to continue from there. And actually in here also we have to just return false in here. So if we explode there, we just return false, and then this function here will return false. That means we exploded, then we can end the game basically. Now, still in this dig function, if it's not a mine, if we didn't click on a mine straight away and the algorithm didn't find a clue in one of the neighbors that is going around, then we can just do self.boardList xy dot revealed equals to true. Now is where it gets a bit confusing, because we have to recursively call this function until we return true, or we're gonna be returning basically. So once we get to a number or to a clue, we're gonna return. So let me just show you this quickly. So whenever you have this, and if you click on a tile, not that one, let's see, no, not mine. I want to, yeah, there we go. So you see I click on this tile here, and it reveals all of this ones up to those clues. We're gonna do a little for loop in here that will check, it will go through all of the tiles around until it hits a number. Once it goes and it hits a number, then it returns true, and then it goes back, and then it goes to the other sides, and then we can go down, and then we keep doing this until we hit numbers. Once we get to the end, then we go back in here, we go all the way up, and then at some point it's going to return true for all of them because they're all going to be numbers. So it's just going to keep returning true into this on function, and at some point we're going to exit this function returning true as well. Okay, so once we don't have more tiles around, then it's just gonna return the function. So that's what we're doing here. So we click on a tile, it's gonna check the adjacent tiles basically, and it's gonna keep checking all of them until it hits a number. Okay, so this one here. So once we hit a clue, we reveal it and then we return it. So we don't call the function again, and we just keep doing that. I hope that makes sense. It goes like this. So we're gonna have a nest for loop, right? For row in range of the max of 0 and x minus 1, and the minimum between rows minus 1 and x plus 1, and all of this plus 1. And then the column will be similar. It's gonna be for column in range of the max. So instead of x, it's gonna be y minus 1, and then the minimum of I guess it would be columns in there minus 1, and then y plus 1, and then plus 1 here. Okay, I hope this makes sense. We're just basically just looping through all the tiles around the one that I clicked on it. And then if the row and the column is not in self.dug, okay, so that's why we are adding that coordinate in here. So if it is not in the dug, then we need to call this function again. If it is, we just pass it on and then we return true. So because otherwise you're just gonna be forever in here calling this function, okay? So that's why we create this self.dug to keep track of all the coordinates that we already explored, let's say. So in here, if it's not in there, then we'll just call self.dig with the row and the column. And then at the end here, we'll just return true. So I hope this is making a little bit of sense. So now we can go back to our main function, or our main file, sorry. And where we said here, dig and check for exploding. So if it's not flagged and we left click on it, what we want to do is if not self.boards.dig. So we're going to be calling that using the mouse coordinates. If it's not, so if it returns false, we want to explode, okay? So that's what it means in here. So if not, so basically if we click on a mine straight away, we want to explode, okay? And then we're just gonna reveal all the mines in the board. So for row in self.board list, and for tile in row, we'll just take that if tile.flagged and tile.type not equals to a mine, we want to do tile.flagged equals false, and then tile.revealed equals true, and then tile.image equals tile not mine. So this basically is if you flagged a wrong tile, which is not a mine behind, okay, so if it is flagged and it's not a mine, then we want to unflag it, we want to reveal it, and we want to change the image to not mine, okay? So what that means is, let's say if I flag a few here, okay, and then I explode, let me explode here. You see all the ones that I flagged, they were not mine before. So that's the image, it's not a mine. Okay, so we'll just give you a warning, like we just tell you this was actually not a mine there. So that's what this part of the code is doing. And then elif type, tile type is actually a mine. Then we'll just do reveal, tile.revealed equals true. Okay, so we're just gonna reveal all the mines in the boards once we explode it. And then we'll, outside of this for loop, we'll just do self.playing equals false. So we just end the game basically. And then if this function doesn't return false straight away, because this will only return false if we click on a mine straight away. It will never return false by recursively calling, okay? So if first time we click, it's not mine, we'll go through this, it doesn't return false, then we'll definitely return true. Okay, it's only when we first click on it. Okay, and then we'll call that function, we'll do the recursively, so if that actually returns false, we explode. If not, we just keep playing the game basically. Nothing's gonna happen. Okay, let's test this and see if that's working. Okay, so I exploded straight away. Can I open something here? I think I have too many mines. Let's put 15 mines in there just to test. Yeah, okay. So that is actually working. And I can flag. And let's say this is not a mine, so it's a wrong mine because the mine is actually here. And I explode. Actually, we can't see because we're not pausing the game. We're gonna do that next, basically. But this is actually working, so you can actually play the game. Okay, like that. These are not, and so on. And if it's flagged, I'm left clicking on it, nothing happens. Okay. Right now, when we explode, it just goes to, whoops, the self.playing is false, so it just creates a new game straight away. That's what we want to do now. We want to just pause that, okay? So we want to create a function that check if we won or not. So if we flagged all the correct mines, then that means we win the game basically. And then we revealed all the other ones. So if there's only mines flagged or mines unrevealed, then we can end the game basically. So we're just gonna create this function that is check win. And what that's gonna do is we're just gonna, again, go through the board and for tile in row. And we're just gonna check if the tile type not equals to a mine and not tile.revealed, we return false, otherwise we can return true in this. So we're gonna be calling this every time we click on we're gonna be calling this on the events down here. And then we're gonna check, we're gonna loop through all the boards. If it finds a tile that is not a mine and it's not revealed, so we return false and we continue the game. If we go through all the rows and it doesn't find any tile that is not a mine and is not revealed, so all the tiles are revealed apart from the mines, then we return true and we can end the game, okay? So even if you don't flag them, you can win the game by just revealing all the known mines basically. And that's what we're gonna check down here outside of this if statement. So it's still inside of the mouse button down, so we'll just check that every time we click on a mouse. If self.checkWin, we're gonna create this variable which is self.win equals true, self.playing equals false, and for row and self.boards board list, we just want to review all the, actually we want to flag all the mines. That's how the actual Minesweeper works. If you don't flag all the mines but you still review all the tiles apart from the mines, it just flags all the mines for you. So for row and then for tile in row, we just want to take the tile, sorry, if not tile.revealed, we want to do tile.flagged equals true, yeah. So that means we win, we reveal all the tiles apart from the mines, then we'll just check for all the tiles in the boards. If it is not revealed, that means it's a mine, then we just flag it, okay? Let's create the end screen now, and then I'll demonstrate everything that I'm talking about now, because so we're able to see what's happening. Just after here, the event, we're gonna define a function called end screen, okay? Basically, that's just gonna pause the screen, okay? So in here, we're just gonna do a while loop, and I'm just gonna copy these events here. Actually, we're gonna copy all the way down to mouse button down. So that's what we're gonna be using here as well. Just so if the user wants to quit the window, we can. And then once we click on the mouse, we just return this function. So then we start a new game basically. And this end screen, we want to call it up here. So in the run, so while self.playing, and else we want to call self.endScreen. Okay, so now the game should be playable. If I die, that's what happens, it reveals all the mines. Okay, and then if I click again, starts a new game. So again, if I flag a mine wrongly, or this is not mine actually, that's what's gonna happen in there. And what was the last thing we want to do is to actually complete the game. So let's just quickly try to complete the game. I'm gonna put the mines down, maybe to 5, and I'm gonna complete the game without flagging any mines. So like that, so I don't need to flag these ones, okay? And I know that there's this is not a mine, and that's what it does. It flags all the mines for you. You can also add a timer if you like. I'm not really going to spend much time on this. This was just the basics on how to create the Minesweeper clone. And yeah, I hope you guys enjoy it. I hope you guys like this new style. Maybe I'm gonna start doing videos like this, a bit longer videos, but just in one take instead of dividing by multiple parts, and just a bit more rushed. You guys can tell me if you prefer like this or if you like more detailed and parts videos. Okay? Let me know what you think. Leave a comment below if you don't understand something. I can try to explain again. And give this video a like if you liked it. Subscribe to the channel for more content on Pygame. And I'll see you guys on the next video.